Okay, class, good morning. So for today, you have this sample problem is determination of latitude and departure. So this is also in notes 3. So you have this problem, you just convert this distance and bearing into latitude and departure. So for the problem, you are given the tabulation below are notes of an open traverse. You are to determine the latitude and the departure of each course and tabulate the values accordingly. Okay, I already have the solutions for this, but I will discuss what is latitude and departure. Okay, so in the Cartesian plane, you have this north, south, east, west line. Okay, north, south, north, north, then south, and then east and west line. For example, you have a line. This one. This is line, example line AB. So you have a bearing or angle. Let's have this as bearing. And also a distance. Okay. So the latitude of a line is its projection onto the reference meridian or the north. So this is now your latitude. Okay, so the latitude of a line is its projection onto the reference meridian or the north-south line, or sometimes that is referred to as northings or eastings. Okay, so this is your latitude. Okay, so latitude AB. For departure, the departure of the line is its projection onto the reference meridian, reference parallel, or the east-west line. Okay, so for the departure, this one is the departure. So the departure of the line is its projection onto the reference parallel or the east-west line. Okay, so this is your departure. Okay, so departure AB. So to solve for the latitude and departure, we have this right angle. This one, right angle, and also this one. So we can use the opposite and the adjacent angle. So to solve for latitude, that is equivalent to latitude is equal to the distance times cosine of the bearing or beta angle. And then for the departure, is equivalent to distance sine of beta or the bearing or the angle from the reference meridian. Okay, it should be the angle from the reference meridian, not on the reference parallel. Okay, and then there is also a sign convention for north, that is positive latitude. For south, that is negative latitude. For east, that is positive departure. And then for west, that is negative departure. Okay? So for the calculation, you are given line AB. You have the distance of 550.30 and a bearing of 28 degrees 10 minutes. So for determination of latitude, you have the formula. Latitude is equal to the distance times the cosine of the angle, or beta, or any name of angle. Okay? So you have 550.30 times cosine of 28 degrees 10 minutes. So you have 483.13. So for the answer, you have positive, since that is north. Okay? So from the bearing, you have that as north, so positive. And then for example, you have for determination of departure, for line AB, you have 550, you have this formula, sine of 28 degrees 10 minutes. So therefore, your answer is 259.76, positive, since that is east. If ever that is no, you have, if ever that is south, so negative. South, negative. North, positive. So but for the east-west line, we don't have a bearing for west. We have only for east. So all the sign for the departure is positive, since all the bearing is going to east. Okay? So there's another calculation. You can use polar function in your calculator. Rectangular function, I mean. Rectangular, then distance, comma, and then angle, close parenthesis. Okay? So in your calculator, you can have shift, and then look for rec, and then enter the distance. Okay? And then comma. For comma, that is shift, close parenthesis. Oh yes, close parenthesis. You have close parenthesis for the comma. And then the enter the bearing. Okay, so for example, you have shift, okay, shift, rec. So look for rec. In my case, that is the minus sign in my calculator, minus sign. Okay, so that is rec. Then enter the distance, 550.3. Then comma, for comma, that is shift, close parenthesis, shift, close parenthesis, so that is comma. Okay, and then enter the angle, 28 degrees 10 minutes. Okay, so you have your answer of X, which is 485.13, and then for Y, that is 259. So therefore, X is, in your calculator, X is latitude and Y is departure. Okay, so that one. So you can use the rectangular function of your calculator to solve for latitude and departure. And then for the sign convention, this one, you look for the direction in your bearing. Okay, so to tabulate the data, you have the tabulation. So the tabulation, latitude, positive 485.13 meters. Okay. And then negative 137.96, negative 409.17, then positive 405.74, negative 307.98, and then 0 for due east. Since when you draw that, this is your east, so you have this line. So for north or south, that is 0, since your line is just going to east. So for the latitude, 0. Okay. For the departure, that is equivalent to the distance. Okay. So let's have for the departure. Departure is all positive. So positive 259.76, and then positive 370.64, and then positive 216.04, positive 483.54, then positive 144.16, and lastly positive 275.86. Okay, so let's try another data to solve for latitude and departure using rectangular function. Let's have the line EF. So shift, look for rect function, and then type or enter the distance 340.05, and then comma, that is shift, close parenthesis for comma, and then enter the angle 25 degrees 05 minutes. Okay, so you have your answer. 307 negative, since that is south. So 307. In our calculator, doesn't have the sign, since we only input the number, distance, and the bearing or angle. Okay, and then for the departure, that is 144.16. Okay, so that's the answer to the problem. You can use this formula, okay, or you can use the rectangular